Without electronics, we cannot live today. Am I right or wrong? Do you agree? Everywhere you are surrounded by electronics. This. All around me is all electronics today. Without electronics, we cannot survive. Of course, we cannot survive with oxygen, without oxygen also. But this electronics has become the oxygen now. How many of you are following Government of India initiatives in the field of electronics, semiconductors? All of you follow what initiatives Government of India is doing? Or anybody can raise hands. I'm not going to ask any questions, by the way. If you know, good. If you don't know, please follow what Government of India is doing for all of us. For you, for experienced people like me, and the upskilling program by Government of India is for all of you. Upskilling. So all of you have to follow what electronics department or ministry of Government of India is doing. I'm sure you will not complain to your principals or HODs that there are no opportunities in this field. If you follow that, you have a way to move forward in your career. If you wait for chances to come, as what earlier principal was saying, you cannot come into the market so soon. You have to struggle. All right. So this slide is what I'm trying to tell is electronics is evergreen field. Without electronics, we cannot survive. So you are in the right choice. You have picked the right subject. Only the question now is you have to excel in this field, and make it count for you to grow in your career. So this slide talks about the ubiquitousness of electronics that is pervasive all around us. Now, all of us know today laptops are so miniature in nature, right? Do you know how big earlier the laptops were, computers were? I mean, you would have studied all this in your courses also, right? And this is one example of how electronics have evolved over the years. It started from mainframes. It was as big as this room. You can call this as big as this room as a computer. This was the computer for in few last years, and later it became a workstation. Now mini computer, personal computer. Now we are talking about sensors. We are talking about laptops. So many. The electronics is not stopping. Electronics is on the course of making lives easier, better, and futuristic also. And all of you students, you have the role to play in making the future of people also more safer and easier. So why laptop has become so thin or small? Why can't it be same mainframe kind of entire room structure? That means over the years, a lot of invention and thought process has gone into make electronics as small as possible and more affordable and more portable for us to use. So this is one example of how much of invention and research is going in the field of electronics. This is an example I want to tell you. Although you may know it, but this is just a precursor of what role play I will be doing with these students over here. So did any one of you ever wondered how is chip getting manufactured? Whatever chips we have in your watches or mobile phones, do you know how those chips get manufactured? Have you ever gone through it? Do you know what is the basic element to manufacture a chip? Can somebody tell me? What is silicon? No, semiconductor is the end product of using silicon, but what is silicon? No, that's understood. It's a semiconductor. The nature of the silicon is semiconductor is very well understood. But what is silicon? Is silicon you can touch and feel or it's imaginary? What is it? Can you touch and feel the silicon or not? Yes, right? So what is the first raw material for the chip to get manufactured? It's a sand. It's a sand. Sand and water. That sand and water is what gets realized as a chip, what we are wearing on our wearable devices like watches or cell phones or laptops, whatever. This TV is all made up of sand and water to start with. Now this particular diagram or rather flow chart, please pay attention. You really get amazed how is the chip getting manufactured in the end. And all of you may not be involved in this, but you can also get an opportunity to get involved in this process also. This is a specialization field for which basic skill set required is electronics, which you're all studying. Basic minimum expect skill set required is electronics, but your study, how does it get translated here, and how does the chip get manufactured here is what I'm going to explain you in detail here, and then we'll get into the role play. So here the start point is this wafer. This is called wafer. It's not, I mean, all of you know wafer, right? Meaning not the biscuit wafer I'm talking about, but even the biscuit wafer that you know, it's very thin and it's made up of, it has some shapes on it, a wafer. This silicon or sand, which is refined so much to remove all the dirt and only gain that semiconductor. What is the sand material that can do semiconducting, not full conducting, not no charge at all, it is semiconductor. They extract it by heating the sand at around 1400 degrees centigrade. They extract that raw material, which is useful for our electronic devices that we are all seeing around us. After this, they make into this shape. This is called as wafer. From here it goes through oxidation. These are all the, I will not bore you with all of the steps, but important steps I'll explain you what happens there, and then you can connect right from the start point where the finish is happening. So here if you see, the next step is oxidation. The word itself, oxidation, means they're implanting the water, oxidation. By doing that, they're cleaning the wafer, and then they're doing photolithography. So the word itself is telling photolithography. Photo is what? Light. They're passing the light on it. Litho means writing. Graphy is also writing. So photolithography. They're passing the light on the wafer. They're passing the light on the wafer, and they do etching. Etching, as you know, in previous olden days in temples, they do etching of god and goddess, right? That similar etching happens here. And implantation, they implant some those called as iodes onto this wafer, and then they do metal deposition also. So why metal? Again, it has to do semiconducting, right? So they do metal deposition, and then the important thing here is photolithography, right? Now this photolithography is where all of you and me including will play a role. Here, how do we play a role in this photolithography is something I'm going to explain through this role play here. So these are all the stages internally happens in the fabrication company. Can anybody tell me one example company who does manufacturing of the chips? Anybody? Can you be louder? I cannot hear. Or you can raise your hand and tell me, because I don't know who's talking. Chip manufacturing companies. Anybody can tell one company name? Have you heard about Intel? Intel does this. Have you heard about Global Foundries? Anybody? Global Foundries? And today in India we are doing this. Before this, there was no company in India who does chip manufacturing. We always procure the chips from other countries. Today in India, we have companies like Micron, Tata Electronics. They are doing this entire process, and that is all through Government of India support. I'm not here to support government here, by the way, just telling you. But what I'm meant to say is Government of India support. This is the right time for electronic students to tap those opportunities that government is giving. This is the right time, because many schemes are coming rolled out by government. You can make use of that. You cannot complain, I don't have an opportunity to connect with the industry, or I don't have a tool in place. You can go to the website. I'm going to show those websites here. You can go to the website. You just have to present your idea, what you want to do. Then government is there to evaluate and support you, along with the colleges, by the way. There is colleges support also government is giving. I see a lot of labs in your college also, where there is a collaboration with Cadence, Synopsys. So those are the some things which are there for your use, and make the best use of them to excel in your career. So this entire thing, right? This whatever you saw here, chip manufacturing, and the final product comes here. The last stage is called as packaging. I'll correlate this example of packaging with Amazon delivery. I'm just telling you a not crude example, a good example, where you order a product in Amazon. Does the product come as is? No, right? It gets packaged and comes, right? They do it in a form of a package where the product doesn't get broken or it doesn't get mishandled or whatever. It comes in the good shape. This is the last stage called as packaging. The chip that you feel and touch in your watches or phones, after you touch also it doesn't get harmed. So this stage, packaging stage, is the important stage, which helps the chip to be very robust. The final chip, the final chip that comes here after testing, this chip gets packaged here and then gives to the for example, Dell company. Dell is the manufacturer of a laptop, not the chip. They manufacture the laptops. That means Dell procures the chips from many people. They make a PCB and they make the final product like a laptop, which we can use in our daily life, right? So those are the people who use this finished product. So this entire process is done in a fabrication company, like for example Tata Electronics, Micron in India, and there are few other companies also in India that have come now, where that is a very clean environment, very clean environment. You have to wear certain type of dress. For this there is a dress code also. We cannot come in normal formal dress or jeans and t-shirt, not like that. There is a special formal dress for that, and diploma and your BTech degree is very much valued there. And this entire process is most of it is automated. Manual intervention is required when there is a chip that is detected as a defect. So your studies will come in helpful here. So this entire process, you can also be part of this and you can shape your career in this domain also. What I am going to teach with this role play is whatever input is getting this photolithography, whatever photolithography input we are passing on to the wafer, what is that these guys will help achieve that I'm going to show to you, because this will be more close to you, what you can understand. This is an example of Intel chip manufacturing. Here there is an idea. It starts with an idea. You have an idea. For example, Intel manufactures laptops, right? They have a next product idea, what they want to do. This idea starts here, and from 1 to 2, the entire design cycle happens. The design cycle, our 6 friends here are going to narrate what those design cycle is all about, and then it goes to the fabrication company, masking operations, die and sort, fabrication, assembly test, finally packaging, and then goes to warehousing. This warehousing people, from this warehousing it goes to all the end product manufacturers like Dell, AS, HP. These companies take those chips from this warehousing, assemble all those chips and make one end product. So far clear how does the chip manufacturing happen? I mean, at a very high level. I cannot go in depth because it might be boring to you, but the interesting part is coming now. But this is how chip manufacturing happens, and to construct a chip manufacturing plant, it requires around $50 billion, 50 or $100 billion. That's such expensive it is. Very expensive, and requires a lot of natural resource like sand and water. Right. So this is what I was talking. You see this engineer, how is he in the lab, in the chip manufacturing plant? You cannot notice who is he also. As long as he's in the plant, he has to be like this, and he monitors the entire chip manufacturing process, what is going on, and then finally he gets to this product. If you happen to see this kind of a chip by opening any laptop in your lab, you can, if you have the facility, you will see the chips like this. This is the chip we see in the laptop, and the companies that are doing all this in India today are Tata Electronics, Micron, Tata Semiconductor, and many more. These are the locations where these companies are located, and you can monitor these companies. You can, when I say monitor, follow these companies to see what opportunities they are throwing at us. We can make use of those opportunities. And minimum educational qualifications like bachelor degree or diploma from ITI, all these are very well appreciated, and the roles include like process engineer, quality assurance, supply chain manager, automation engineer, and this guy is called as technician here. He's a technician here. These two are also technicians. There are roles for technicians and designers. These are these people who are in the lab. So this is another field wherein you don't need to know how to design the chip, but you should know how to manufacture the chip. Now coming to chip design cycle, right? This is where our students will help in doing a role. Let's imagine we want to design a laptop. I'm guessing. I'm just taking an example. We want to design a product or a traffic light controller. I'm just telling an example. Let's say, sorry, your name? Chatur. Sorry? Chatur. Okay, let's say Chatur is the project manager for this. So your role is project manager, okay? He's a project manager, and he got a requirement from Government of India. Let's say customer is Government of India. Government of India wants to develop a laptop for India. I'm just telling an example. And they found Chatur is the right person to give the contract to. Chatur is the right person to give the contract to, and he's leading entire 6 people here. He's a project manager here. All right. So he knows. He comes to me. Let's say I'm representing government here. I'm coming from Government of India. I go and tell him, Chatur, I want a laptop that is less costly. I mean, cheaper than the best laptops that other companies are building in the around the world, and I want minimum features. For example, all of us want USB. We want Ethernet. We want Wi-Fi. We want maybe HDMI. We want USB port to connect headphone. So these are the features. I'm going to go and tell Chatur, please, can you develop a product for me? And he will think and come back and tell me, can I do it or not? So how is he going to do that? Is with his team members, the other 2 and these 3 gentlemen here behind me. He is going to discuss with all of them and come back and tell me whether I can do a product of what I'm telling him. This is how electronics gets evolved. First, idea or requirement. Idea or requirement comes for some companies like let's say I'm coming from Government of India. I want to design a laptop and give it to the less income people or poor people. I mean less income people I would say, where they cannot afford 30,000, 50,000 rupees of laptops, but they can afford maybe let's say 10,000 rupees laptop. I want him to do that. Can he do that? He will go and assess. Now to do that laptop, what are the skills his company should possess? What are the skills that his company should possess? I should have analyzed before coming to him, because without knowing his skills or whatever his skills are there, without knowing that I cannot go and offer the project to him, right? I cannot give the contract to him. So here Chatur is going to first listen to my idea here. He listens to my idea. My idea is designing a laptop. My idea here is designing a laptop. Now he will ask me 100 questions, 1,000 questions. He'll ask me, Mahesh, what is that laptop you want? What is the form factor you want? What is the features you want? Or whom are you trying to sell this to? And how much power it should take? What is the speed at which you want to operate? He'll ask so many questions to me because he's a subject matter expert. I believed him. I know his skills. He'll ask me all those questions, and then finally he understands my idea and he should give me the chip. That is his role. He should give the chip. Now how he will give the chip is with taking help of these 5 other colleagues from his company. He is going to take help of these 5 people. Now how does it start? It starts with specification. Okay. The word specification is clearly understood now. Whatever I am telling verbally, it should be documented. Like I want USB, I want HDMI, I want PCIe, or I want Wi-Fi. All that I am saying I want, but I should put it in a documentation called a specification. It starts with this. Now next is architectural design. Let's say this engineer, sorry, your good name? Divakar, right? Divakar is an architect in his company. Now what this Divakar and Chatur is going to discuss Chetri is going to tell that Mahesh from Government of India has come with a requirement to design a laptop. Now he is an architect. He will tell, okay, we can do it, but I can draw a picture for you how a laptop looks like. Or let's correlate to this example. Let's say Chatur wants he wants to build a house. Very simple example, not laptop. He wants to build a house. Now first thing what you do when you want to build a house, what is the first thing you will do? Can anybody tell me how you want your house to look like is what you will have in your mind, right? How you want your house. What is that called as? Plan, right? It's a plan. That planning is something Chatur is going to tell to Divakar. Divakar can imagine and translate that imagination into a architecture diagram. Meaning he can draw the blueprint of the house. This is where the staircase will come, this is where the parking will come. He can show pictorially by doing a blueprint. That role is called as architect. He is very good at that. So that's where this architectural design happens. Whatever specifications I told, like USB, Wi-Fi, and Ethernet, HDMI port, all those architecturally he will draw the block diagram. Divakar is very good at that. He will draw the block diagram and tell to Chatur, this is something we can do, and Divakar is going to come to me and Chatur is going to come to me and tell Mahesh, this is what we want to do. This is your requirement. This is what we can do, and are you okay with it? If I say okay, he will go to the next step. Coding, RTL coding, and functional verification. What does this do? I'll be explaining in the next slide, but I think all of you know what is RTL here, right? Everybody knows what is RTL here? No? Guys, be louder. No, I am only speaking. All of you, right? I mean, I'm guessing you all know what is RTL, right? So now architect role from Divakar is done. He told this is how the laptop is going to look like, and this is what we can offer. Now let's say your good name. Sorry, Samir. Yeah, he's Samir. He's very good in coding. When I say coding, why do we need to coding? I'll tell you one example. Again, I'll go back to the constructing a house. Let's say Divakar is an architect. He has told you have to use, let's say for building a wall, you have to use 100 bricks. He gave the specification in the architecture documentation. To build a wall, you have to use 100 bricks. Now, Samir, who has the bricks with him? Now, using the bricks, he can construct a wall in a rectangle shape or square shape. It is in his skill. He started placing the bricks in a proper way, and that placing the bricks in a proper way is equal to designing the feature of the laptop. For example, he wants to design the USB. To design the USB, the material that is with him is coding. You understood? Are you able to understand what I am correlating the example with? Constructing a house with bricks. Bricks is his weapon, or I can say weapon to realize the wall. For him, the weapon to design the USB protocol is USB interface of the laptop is RTL coding. He can choose Verilog, System Verilog of his choice. Whatever skill he is good at, he can do it. But for that to do, he has to know how the USB protocol operates, right? For example, in the laptop, you connect USB, immediately you are able to do data transfer. How is that happening? Can anybody guess how is that happening? A wild guess. I don't want protocol knowledge. A wild guess. How does the data transfer happen? You are connecting pen drive. What is that immediate action happening once you connect the pen drive into your laptop or any other portable device? What is it happening? Just what you think, you tell me. Anybody, just raise your hand and get up and tell. I don't think whatever your answers will be will not be correct. I think they will be correct. You can stand up and tell me, because I cannot see who is speaking. Anybody? Once you connect pen drive, what is happening to your laptop? I mean, so many people want to tell, but you are not standing up and telling. Okay, I will only tell. Once you connect the pen drive, first thing that happens is the pen drive should get detected, right? It should get detected, no? The laptop should tell pen drive some name. So let's say pen drive name is Mahesh. Once you connect it once you go to your Windows home drive, it says Mahesh pen drive is connected. right? How does it happen? Immediately you're connecting something and software is showing Mahesh pen drive is connected. How is that all happening? Because our so you're going Samir has written the hardware inside the laptop. Once the pen drive is connected, the pen drive is sending some instructions or some data to the design he did in the coding, RTL coding. What he has done is that USB pen drive is made up of 4 or 5 signals. If you open the pen drive and see, there will be 4 to 5 lines, thin lines, those are wires. Those wires get connected to the chip that he has done the coding, meaning he has done the USB protocol coding. USB protocol coding, that is the industry standard. Let's say this set of people, this first 3 girls sitting here, they have defined the USB protocol. How does USB protocol should happen? By protocol, anybody understands what is the meaning of protocol? Understood meaning of protocol? Do you know the meaning of protocol? Sorry? You know? Flow, right? You are saying flow, right? Yeah, exactly. What should happen and when and what should happen? That is called as protocol. Or another protocol I can tell you, we have lit the lamps and then I started presenting. That is a procedure, right? Similarly, once the pen drive get connected, these 3 gentlemen sitting in the top, in the first row, they have designed a specification for USB technology. These all things have to happen with these 5 wires, and that what should happen is given in the documentation, and Samir is going to follow that. He is going to follow that protocol and write in the form of a Verilog language or system Verilog. He is very good in coding. That is the role of Samir here in this project. And let's say, madam, your name? Drishti. Srishti, the role of Srishti is to verify what Samir has written, because it is not guaranteed whatever he writes will work. They have these 3 gentlemen sitting here has written USB protocol saying that once the pen drive is connected, data should go, saying that it should detect it should read the name of the device and display it on the laptop. That entire sequence they have written, and he coded also in the Verilog language. And once it coded, Srishti's job is to verify what he has written is indeed correctly done or not. That is the role of testing engineer, verification engineer. That role in India today is in very demand. Srishti's role is in demand a lot here. For that, what you have to possess skills, and I can tell you at a high level what is the salaries also you will get in that role. But that Srishti's role is in demand in India, I'm saying. But Samir's role is in demand in abroad. Less in India, but more in abroad, a design role. And whereas architect role is more in abroad also. Project managers we have abroad in India, not an issue. But the skill set wise, the opportunities wise, for design it is more in abroad. And architecture also is more in abroad. I'm not saying zero in India, but more in abroad. But verification, what Srishti is doing for this product laptop verification, her role is more in India. So that role is here, RTL coding and functional verification. Srishti is going to do verification of whatever he has coded. Now it comes to synthesis. Let's say these 2 gentlemen here are part of these 2, the rest of the stages: synthesis, physical design, verification, and then giving of the final net list to the fabrication. I mean, I can take the role of fabrication here just because we want to continue the session. What is the role of, madam, can you tell me your name? Ramya and? Sorry? Rabika. Okay, Ramya and Rabika here are from physical design and until physical verification. What does it mean here? Now, he has written the code in Verilog, right? And Srishti has verified it in using system Verilog or UVM, whatever language. Now, once verification is done, we have to realize the USB in the form of a hardware, right? The pen drive that is connected to my laptop, I can touch and feel, right? How is that happening? Without Ramya's and Rabika's help, we cannot do it. They are the ones who are making it to realize in the form of a hardware. They are the ones. Whatever Samir has written, it's a representation of how the chip should work, how the functionality should work. But realizing that into the hardware is the role of Ramya and Rabika. They come here. They do the role of physical design. The word itself says physical. That's where you can do touch and feel. Physical design. Here physical design means the transistor level. We would have learned transistors, AND gates, NOR gates, flip-flops, all that. They are the ones who are going to make it realize to happen. In my fab, it undergoes entire process like this. here. That is where this Rabika's inputs will come. Rabika will give me her final output and I etch it on the wafer here. And the entire process goes here, and I ensure entire process happens here, and I give the finished product in the form of packaged chip, and I give it to here is the manager, right? He gives back to me because I am from Government of India. I give the requirement, he has to give the chip back to me. Have you guys understood whole process here? Who does what here? I'm not here to teach every stage in detail, but the essence of how really chip gets manufactured, you understood, right from the idea to the role of project manager, to the role of architect, to the role of designer, to the role of verification, to the role of physical design engineer, and importantly, the role of fabrication engineer. Without me fabricating, you cannot do whatever the code Samir has written. I have to manufacture using silicon, sand, and water. And the role of photolithography is, have you guys used in all our school days, we have used something called a stencil. You remember stencil? All of you know stencil? What is stencil? Basically it has alphabets and numbers in it, right? Using stencil, you can actually write that number and alphabet the way you want. Here also, in the photolithography, whatever Rebecca has given output, right? The light is passed through that stencil. That means the transistors will be formed in that shape itself. That is why it is called as photolithography. Litho means that output of that mask is coming the transistor shape and getting etched on this wafer. Are you able to understand why I should pass light? Can somebody tell me why I should pass light onto that stencil of output that Rebecca has given me? Why? Because when you pass light, exact shape of that transistor reflects on my wafer, right? Like what my shadow is forming on this thing, right? Light has to fall through to take the shape of your mask or stencil. Same thing happens in this photolithography also. Without any source, you cannot reproduce what Rebecca has given here as an output. Understood? So now let's see the roles. We have front-end role. These three gentlemen fall under front-end role. They are the first person to understand the requirements. In this role, I mainly come from this front-end role. My role here, my specialization falls under this front-end role. I define the architecture, microarchitecture, coding, and verification. So these all things happen. See, product idea is laptop. Finally, I have to achieve this laptop, meaning the project manager has to give me this laptop. I only told to him I want this kind of laptop. He has to give me a laptop that I can touch and feel the laptop. That is his skill. He has to give me that. I am paying him the money to give me that product. So now, what are the job roles we have in India? Architect, micro-architect. I hope, Divakar, you understood your role of architect, right? You understood the requirements from your manager. You are documenting in the form of an architecture diagram. Like I told you, building a house. Like project manager says, I want a 3 BHK house with parking, a swimming pool, something like that. He'll tell. Now you have to picturize it and show it to your manager. This is how it looks like. And that is the role of architect and micro-architect. Designing, Samir's role, designing and coding and verification, Srishti's role. Verification is important here. And what are the skills that you need to possess and which you can make use of for your college facilities is the learning of Verilog, VHDL, System Verilog, UVM, and I believe all of you would have heard of these names or some of you would have had experiences also. These are most in demand in India. And what are all the companies in India like Intel, Broadcom, Qualcomm, and many more who can do this entire thing in the company? In this domain. And there is something called as the design for test, which I didn't take. I should have asked for seventh person also here. But there is a domain called as the DFT, design for test. Now let's say I manufactured the chip. and have given it back to manager. His role is to ensure the chip is functionally working correct or not. Srishti has verified whatever he coded, but who is going to verify the chip that I manufactured is working fine or not? Who is going to verify? That this team, design for test. They are the ones. They take the chip, they run some test vectors on it and ensure whatever verification Srishti did, they will do it on the chip directly. So what Srishti verified is the coding done by Samir, which should be done. Once the chip is manufactured, how are you guaranteeing the chip is working fine or not? That is the role of design for test engineers. So there is the roles like DFT architect, DFT RTL verification, post silicon. These are all the roles that are available, and this is also in demand in India. Not as much as what's Srishti's role, verification. This is the second most role that is in demand, and this is many companies are there, like where I come from, Keen Semi. We have opportunities in Keen Semi also. We have opportunities in Intel, Broadcom, Qualcomm, TI, a lot of companies, and these are based out of Bengaluru, Chennai, Hyderabad, Pune, Noida. So it is well spread across India, and DFT is another field you can all get to know in detail. Verification, I have already explained you the role of Srishti here, right? She has to know she has to understand first what Samir wrote, and she has to ensure Samir wrote correctly or not. That is her role. That is a very important role. That's why the job opportunities in India in verification role are very high. So what type of verification roles? Once design verification means whatever Samir has written, she is going to verify, and her role is also important. Once the chip is back from the fabrication, whatever she has tested on the code, she should test the same thing on the chip also. That is why it is called as post silicon verification. Once the silicon comes back, that is called as post silicon verification. So that is also in demand, and there is a role called as emulation. Will this emulation engineer, whatever chip whatever product these three people have done together in designing and architecting, that should be verified before the silicon comes in a very fast environment. You should emulate the chip. That is called as emulation engineer. That is also in demand. For that you have to learn Verilog, system Verilog, digital design, UVM, OVM, and you should also have very good knowledge of this latest protocols: USB, DDR, high bandwidth memory, UCIe, PCIe, Ethernet, CXL, AXI. These are, and a lot of companies are there here. Keen Semi is one of those companies whom we have a lot of expertise in this domain. And backend, the role of Ramya and Rebecca. Here this also is in demand in India. I would say third in demand wise. Verification, DFT and STA, especially a lot of the outside India countries, they look at India to provide skills for this. They need people in this domain from India. So what are the skills you need? You need to have conceptual understanding of Verilog. You don't need to do code, because Ramya does not need to write code here. Coding is already done by Samir. Ramya only needs to know what, at a high level, if Ramya wants to see the code and see has he written fine or not, you can just understanding is enough. She doesn't need to code. Her role is to do the transistor level realization. For that she has to have good understanding of capacitance, decapacitance, resistance, current, voltage, temperature. These are all the things she has to be well she has to have good concept knowledge. And there are a lot of companies in India also in catering to this. Sorry, it is my typo. It should be BE, not FE. This field is called as backend field. BE. It's a typo. It should be called as BE. And a lot of companies like Intel, Broadcom, Keen Semi, we all offer a lot of services in this domain. And one last slide before I conclude. Like I said, Government of India is having a lot of schemes for students. Predominantly for students, next for the companies. For students, there are a lot of initiatives taken by Government of India. The one such scheme is design linked incentive. If you go to this website, you will be able to know what is government is doing for what schemes government has rolled out for students. And there is another ministry called as Ministry of Electronics and Information Technology. This also provides technical internship program. Very important. If you want, and if your college allows you, go and register for this, and this is a website. I hope with this role play, all of you have understood how the chip gets manufactured, who does what, and where is the skill, what skill you have to pursue. One thing I did not touch is on the salaries, right? I mean, most of you, I mean, not just you, me also, we all want to make an earning for life, right? So if you ask me what type of domains will give a lot of, not lot of money, good money, is in the field of front end, verification, and back end. These